Okay, so for this problem, we have a given water that is entering through this thin copper tube at this internal diameter of 2.5 centimeters. So it is entering at 15 degrees Celsius at a rate of 0.3 kilogram per second. And then the steam condensing outside of this tube is 120 degrees Celsius. No? And then we have the average heat transfer coefficient given 800 watts per square meter Kelvin. And then you have the length of the tube, or determine the length of the tube required to heat the water at this exit temperature of 115 degrees Celsius. So assume that the thermal resistance of the copper tube is negligible. So we don't have a thickness basically, ano? So how do we solve now this problem? No? So we want to determine the appropriate length, no, to properly heat this steam. Okay, in this given analysis, we can say that the surface temperature should be constant, no? So it is condensing outside at this temperature. So probably the temperature is constant. So we can use the analysis of Q is equal to HA times delta T, no? So the delta here is the logarithmic mean temperature difference, no? So the delta T Lm is equal to Ti minus Te over natural log of Te, or actually Ts minus Te over Ts minus Ti. Okay? So what are the givens here, no? So we want to find the length, no? So basically the area first, and then based on the diameter, we can find the length, no? So is the Q here given, no? So it is not really given here yet. But we have the mass flow rate, no? Okay, so we need another equation. So the Q here is also equal to mCp delta T, which is Te minus Ti. Ayan. Okay. So in here, we can solve for Q given the mass flow rate. So m dot mass flow rate is given. So the Cp can be found. Te is given, Ti is given. Then find a Q. So if Q is given here, and H is also given, so delta TLM is just a function of Ti and Te. So this is also given. We can find the HA, no? Sorry, the area, which is basically the area here of the surface here, no? So we have the surface area of a cylinder is pi dl, no? So given this, we can find the L given the diameter, no? So pi is just a constant nga pala, no? So in here, how do we now solve this one? So we want to find the CP. You can approximate the CP by just using 4.1, no? But since we will use tables here in this topic, we want to find the CP at this appropriate temperature. So we want to evaluate the CP at the bulk fluid temperature TB. So TB is just the average of the exit, no? Ti minus Pi plus Te over 2, no? Average of the inlet and outlet temperatures. So this will be equal to what, no? So you have 15 plus 115 over 2. So you have this will be 65, no? So 130 over 2 is 65. So we have to evaluate the fluid properties at this temperature. So in here, as we can see, we have 65 here. So the CP here that we will use is 4.187. So TB, CP here is equal to 4.187. I will not write this anymore pala, no? And then what else, no? We only need the CP. No? So we can find now the Q here. So Q here is equal to, the mass flow rate is 0.3 kilogram per second, and then CP is 4187. No? So we have joule, kilogram, Kelvin, and then the temperature difference, no, of the inlet and outlet. So we have 115 minus 15. So Q here is equal to what? No? So doing some analysis now, we have kilogram per second, we have kilojoule, sorry, just joule, no, joule per kilogram Kelvin, and you have Kelvin here. So the unit will be joule per second or in watts, no? Okay, so using our calculator, you have here 0.3 times 4187 and then 100, no? So 115 minus 15 is just 100. So you have 125,610, no? So this will be in kilowatts, no? You can write this in kilowatts if you want, no? So I guess I'll just write this in kilowatts to just conserve some of the space, no? 125.610, no? 61 kilowatts. Okay, so now we have defined the Q here. We want to now solve for the area. So for the area, we want to find the AS, no? Area of the surface. So AS here is equal to, so rearranging this, no? You have, actually we need to find the log mean temperature difference first, no? Okay, let's solve for the log mean temperature difference first. So TLM is TI minus TE. I guess I'll just use the calculator directly, no, to preserve a little bit of space here. So you have TI minus TE, so 15 minus 115, and then the natural log of TS, so 120 minus TE, 115, 120 minus 15. So the log mean temperature difference is 32.85. No? 32.85 degrees Celsius. Okay. So in here, we can use this one for this one. No? So to find the area. So Q here, oh sorry, the area here is equal to, you have Q over H and then delta T the log mean temperature difference na lang, no? PLM. Okay, so this will be equal to, so we have 125.61. So this is in kilowatt, no? Take note of this. So you need to reconvert this again into watts, no? So 125,610 watts, no? And then over H here is in, because the H here is in watts, no? So you have 800 watts per square meter Kelvin. And then you have the log mean temperature difference, which is 32.85 degrees Celsius, no? So the area here should be in what, no? So if you do an analysis, this should be in square meters, no? Sige, let's solve this one. So 125,610, and then multiplied by 800, or divided by 800 times 32.85. So the answer is 4.77 or 78 na lang, no? 4.78 square meters. Okay, so this is not yet the final answer, no? So finding the length here, we can use the surface area, no? Formula of a cylinder. So the length here will therefore be AS over pi d. So you have 4.78, okay, 4.78 over pi, and then the length, the diameter here is 2.5 centimeters. So this will be 0.025, no, meters, no. So the length here will be, let's see, so 4.78 over pi times 0.025. So the answer is 60.86. Okay, 86, no, meters. So this will be your final answer. Okay, so what is the significance of this problem, no? So you can imagine if you are, let's say, trying to design an air conditioning system, no, or a cooling coil, or in this case, this should be a condenser coil, no, for condensing the steam. You can design how long your tubes should be to approximate, no, this outlet conditions, no? So you need to have this length of 60 meters, which is quite long, no? So we usually use um, um, coil circuiting, no, to make this possible. So um, you just have to make the length 60 meters, no? Okay, so that's it. Thank you guys for listening.